Have you ever wished you had a superpower? Well, what if I told you there's a tool out there that lets you see the invisible force of electricity? Today, we're going to unlock the secrets of the multimeter and learn how to see inside the circuits that power pretty much everything in our world. You know the feeling. We've all been there. Your favorite gadget, a piece of equipment you absolutely need, it just stops working. So you open it up and you're staring at this mess. It's just a total jungle of wires and components, a complete black box.
It's such a frustrating question, right? And honestly, without the right tool, you're pretty much just guessing. But that's where the multimeter comes in. It's your secret weapon. It lets you stop guessing and actually start diagnosing. So let's dive into how it really works.
Now, using a multimeter isn't just some cool hobby skill. It's absolutely essential. And the stakes? They're way higher than you might think. See, a wrong move here isn't just about a bad diagnosis. It can be a real safety risk.
This quote right here really hits the nail on the head. One wrong connection and you could damage your gear, or much, much worse. And that is exactly why understanding a few fundamental rules is so critical before you even touch anything. And you know what? It all comes down to this one simple but totally crucial difference: parallel versus series. Think of it like this. Voltage is like water pressure between 2 points in a pipe. To see that pressure difference, you have to measure across those 2 points. But current is all about flow. So to measure that, you have to actually get in the flow. Let's start by unpacking what across really means when we talk about voltage. So think of voltage as the electrical pressure that's pushing everything through a circuit. And to measure it, you always, and I mean always, follow the parallel rule. The great thing is this means you never have to cut a single wire. You're just tapping in to check the pressure difference between two spots. The actual process here is super simple and safe. First, you just pick your voltage type. That little wavy line is for AC, alternating current. You know, the stuff from a wall outlet. The straight line is for DC or direct current, like what you get from a battery. Then you just touch your probes to either side of whatever you're testing. That's it. That's all there is to measuring across it. And you're going to run into different AC voltages depending on what you're working on. A standard home outlet, that's about 120 volts. A big appliance, like a clothes dryer, is going to be 240. And in industrial settings, you can see stuff all the way up to 480 volts. Knowing what to expect is a huge part of setting your meter right, and of course, staying safe. Okay, let's totally switch gears now and talk about measuring current, which you'll also hear called amps. This is where the rules change completely. For current, you absolutely must follow the series rule. Right, so unlike with voltage, your meter literally has to become a link in the chain. Let's go back to our water pipe. Current is like the amount of water flowing through that pipe every second. To measure that, you can't just touch the outside of the pipe, right? No, you have to cut the pipe and insert a flow meter into it. That is exactly what you're doing here. You physically break the circuit and stick the meter in the path, forcing all the current to flow directly through it. Okay, I need you to pay close attention here, because this is the single most critical warning of this whole explainer. If you try to measure current by putting the probes in parallel, the way you do for voltage, you create a direct short circuit. I'm talking, you'll blow the fuse in your meter, you'll see a big flash, and you could very easily destroy the tool for good. Just remember, amps are always measured in the path. And finally, let's look at the third one, resistance, which is measured in ohms. Now, this has a completely different role, and for your own safety, it is the most important one to remember. We call it the power off rule. This is 100% non-negotiable. Before you even think about turning that dial to the little ohm symbol, the circuit has to be completely dead. Why? Well, it's because the meter sends out its own tiny bit of voltage to measure the resistance. Any outside power in the circuit is going to give you a totally wrong reading and will probably fry your meter. So, once the power is safely off, reading the meter is pretty straightforward. If you see OL, that means open line. The path is broken somewhere. Think a blown fuse or a bad wire. A reading near zero means you have continuity, a nice solid connection. Anything else, any other number, is just the resistance of whatever component you're testing. All right, so we've covered the 3 core measurements and their big rules. Let's just do a super quick quiz to make sure it all sticks. You ready? Question 1. You need to check the voltage at a wall outlet. How are you going to place your probes? You got it, in parallel. The probes go across the 2 slots. You don't have to break the circuit at all. Okay, question 2. You want to find out how many amps a little motor is drawing. How do you hook up the meter? Yep, in series. You have to break the circuit and put the meter right in the path of that current. And for the final and most important safety question, what is the number one absolute can't forget it rule before measuring resistance?
Power off. Every single time, no exceptions. You have to make sure that circuit is completely, totally de-energized.
Really, it all just boils down to this simple little mantra. Voltage is measured across, amps are measured in the path, and resistance is always, always measured with the power off. If you can burn these 3 rules into your memory, you'll be able to safely troubleshoot just about anything.
So now you have the key. You can actually look inside a circuit and see what's really going on. You've basically got the power to see the invisible. So the only question left is, what are you going to fix first?